All right, good morning class. How are you? My name is Dr. Emmy MUGISHA and I work with computing and information technology sciences, or what we normally call as the Faculty of Computing and Information Sciences in UNILAK. Today we are going to look at the module or the course that is called Data Structures as second year student. So every second year student at his or her year 2 level, he or she needs to take this course that is called Data Structures. So it is called Data Structures. So we need to look at the description of this module or of this course for you to know what is going to be happening at the course of this time that we are going to be spending with you as we deliver this module. So this course gives you the wider view of what is data structure and different ways we can embed data structures within the development of softwares or in any other structures through which we can store the data. And also we look at different performance techniques that can be considered for a data structure to be of a good performing mechanism through which we need to base on as we build our data facilities or data storage facilities. At the end of this, the whole of this is to give you the basic foundations of the theoretical part and the practical part that leads you to a computer science student that is capable of understanding what is a data structure. So we expect that so we have looked at the description of the data structures, and now we are looking at the outcomes or learning outcomes that we need to expect from this module. So first of all, as the student at the end of this module will be able to select and apply appropriate algorithm that would lead you to an efficient or an appropriate way of which you can store the data. It means you have to know what are the algorithms that I need to apply. We will see what kind of algorithm that we may need, and then in the application of the algorithm, through that you may be able to understand which kind of data structures that will be able for you to model, analyze, and deal with some computational problems. And at the end, you'll be able to observe and store data appropriately, because the main concept of this module is for you to have a brief idea on how you can store your own data, right? Great. Now we can look at the course outline. What is going to be involved? What are we going to find? What involves within this particular module? So we have different units through which this course will undertake. So we have different units in account. There are 6, and the first one is what we call the introduction to algorithm, that will introduce to us what are the possible steps that need to be taken to solve a particular problem. Every problem can be solved as if after following a particular step. That is what we call an algorithm. So we look at the introduction to algorithm in general, and also we will look at so it is the outline. So under outline we have what is an algorithm, and then we look at the algorithm presentation. That is the second unit, and the third unit is about the linked list, the stacks, and queues. These are what we normally call linear data structures. So normally data structure as a module, it is divided into 2 parts. That is what we call the linear data structure and non-linear data structure. So in Unit 3, we look at the linear data structure. It means for these structures, this is where we have different examples that we needed to deal with when we look at them. Every type of data structure, there is an example that can be given. We will look at that as well. And in Unit 4 also, we have what we call non-linear data structures. These are also other kind of data structures through which a programmer can use to structure his data in a manner that can easily be stored and accessible. So with linear and non-linear, we will see the difference in the near future as we go on in our module delivery. We also have the lesson 5, which is what we call the sorting and searching techniques. That means these are mechanisms, or these are techniques. In actual sense, they are algorithms, or they are programs or functions that which we can use to apply on the mentioned type of data structures, whether linear or non-linear. So we can also have a mechanism through which we can sort the items that has been stored in the given data structure. And the other side also, we can also search. So sorting, it is ordering items. Then searching, it is finding a particular element if it is involved in a given data structure. So we also look at those techniques in Unit 5. And the last unit is what we call files. So we also look at the different files or different methods through which file itself is also what we can call as a data structure, which can also accommodate or store different data through which we can use in our normal lives. So we will also see different applications that we can apply, or operations that we can apply on files, and through where files can also be used in our normal way of organizing data during the software engineering level. Then, after all these units, that is when we come up to meet the learning outcomes as we have mentioned earlier on. So the next thing, as a student, what we expect from you as your requirement is you need to know that this course is going to be delivered in blended mode. That means there is a percentage of meeting you face to face, and there are other percentages that is going to be delivered online. What does that mean? It means that there are some activities that will be delivered online, of which you need to pay much attention and concentrate and be able to participate in every online activity that is going to be delivered through e-learning platform or online. And the other percentage also will be taken for physical face-to-face. So in case we are together in the class and we are going to be discussing together, having physical contact, that is also going to account. So you need to be sure that you have used your time efficiently and know exactly what is happening in the class. So also resources that is needed for learning and participating in the course of delivering this mode, all resources will be advertised or published online through the course platform. And also, another thing that you need to know is about the assessment. So whether activities that has been delivered online, there will be some assessment that will be undertaken to those particular activities that has been delivered online. And also there are some other activities that will also be assessed during face-to-face. So all those activities, we call them formative. That means we'll be looking at those particular class exercises and other given assignments that need to account 60% of your final assessment. And then we will have a summative assessment of which it will need you to meet at university facility and then have a face-to-face exam, a written examination that needs to be invigilated and following the examination procedures of the university. So you need to be careful. The activities will be taking 60% of your assessment, and then the 40% will be taking the 40% of the assessment. Be careful about that. So now we can go to our today's unit, which is Unit 3, that is about Unit 3, which is about the linear data structures. Unit 3, that is linear data structures. So here we have list, and then we have stack, and then we have the queue. These are the particular examples of linear data structure. So let's go now and hit on the definition of what is a data structure. We can go on and we will look for this question later, and we need to ask ourselves, what are data structures? Previously, we have looked at different, for those whom we met recently for the first classes, we have looked at the algorithm, and then we looked at the algorithm presentation. Now, today, it is about the linear data structures. But before we go into deeper examples of linear data structure, we look at now what is the data structure itself by definition. So it is a mechanism of storing data efficiently. Storing data where? It is storing data in computer efficiently. That is what is data structure. Data structure is a way of storing data to the computer efficiently. So that how efficient can it be? Why do we say efficiently? It is efficient that if we need the data, we can easily locate it. If we want to apply some operation on data, we can easily apply these particular operations on the data structures or on the data that is stored in the data structure. So if we don't have data structures, we cannot easily access data that is stored inside these data structures. At the same time, if we don't have data structures, we cannot even easily apply some operations on these specific data structures. So that means data structure, we will see in details what are the ways we can apply different operations on a given data structure so that we can have a clear understanding. So what we call that, when do we need to choose a data structure? It depends on the abstract data type, like as we say. Abstract data type, it is a logical description of how we view the data and some operations we can apply on the data. So you see the DAT, the abstract data type is what you call the abstract data type. It is concerned on how we view data and what operations can be applied on the data. So given data, we can see how we can view them. That means how we can present the data. And then if the data are well presented in the given data structure, we can also easily apply some operations on this specific data that is within the data structures that has been given. So the next thing is now why we needed to organize our data in a given agreed manner. It is a matter of saving resources. Why do we need it to save? To have a data structure that is easier to view the data and easier to apply operations on the data. It is as a result of having resources shared easily, and also save some time and save some space. If a data can be accessed easier, that means it saves time to do other things. And if the data can easily be accessed by the use of different facilities that we have, those are resources. If the resources we have can easily allow us to access the data that is stored, that is a few things that need to be considered. For space as well, if the data that is occupied the space on the computer, if it is taking less space, it is also a good thing as a well-designed data structure. So it must have less resources used, time and space that has to be considered. Yes, and then we can look at here, we can see some of the commonly used data structures. In this case, we have combined both linear and nonlinear commonly used examples. In this case, what you see on the slide, it is a combination of linear and nonlinear data structures as examples. So we see different examples. We have, for instance, we have list, we have arrays, we have stack, we have queues, heaps, trees, and graphs, and etc. These are commonly, so we have many and they are combined. So we can now see in the data structure how data structures can be classified. So we have simple data structure and we have compound data structure. We have linear data structure and non-linear. So we'll be focusing on the last two. That's where we should be focusing, the linear and non-linear data structures. Yeah. Yes, go ahead. Yes, here. So for linear data structures, that means these are type of data structures that can help us to store the data linearly, straightforward. That means this kind of data structure, they store the data that we have linearly. That means there is an agreed sequential manner of dealing with data that is going to be stored within these particular data structures. So that means if data is going to be stored in the given linear data structure, it means it does not, it considers what we call the relationship of adjacent data items. That means the relationship of adjacent is maintained. It means if the data coming to be stored in the data structure, it does not depend on the current data structure inside, but it is just added linearly. Where the available space is, it's where it is stored. That is what we call linear. But within non-linear, the adjacency of the relationship is not maintained. That means, it is maintained with non-linear data structure. It means the data is stored based on the relationship of the available items within the data structure. That is linear, non-linear data structure. With linear, the data is stored sequentially. It does not matter the current data that is inside, and then the item can be easily added. We will see that. So there are operations that can be applied on linear data structures. So given those data structures that we have we are talking about, what are the possible operations? So remember the other time with the concerns, the well-designed data structure, it concerns how we view the data and the operations we can do, what we can apply on the data. So these are one of the operations that can be applied on linear data structure. So we can say operations, then one, it is add item, delete item, traverse item, and then we can search, and also we can sort. These are different operations that we can apply on different data structures in linear data structure. Every operation is a standalone algorithm. That means it is a function which is a list of different steps or a block of code that execute this particular operation. If it is adding an element into a given data structure, it is a function or an algorithm to deal with that specifically. And if it is deleting, traverse, sorting, and etc. We will see all these in details as we go on. Yes. So we can also see as an example, for instance, here we see the now examples of these linear data structures. It is where we have now list. These are specifically for linear data structures. Then we have queues. Then we have stack. We will look at this mainly in this class. But we also have what we call linked list tables, and etc. All these are examples of linear data structures. Then we can go on the next slide. So okay, we can look at the previous slide and look at, we have defined what is nonlinear data structures, and now these are what we call, it has the same operations, but the type of data structures in nonlinear, they are different, but the operations, they are the same. It means for nonlinear, when we look at it, nonlinear, we have trees, we have graphs, and we have hashing functions. So that this means also for these nonlinear data structures, we can still have the same operations that we can apply on them, which is the delete, add. We can add items, we can delete items, we can traverse, we can sort, and we can search an item from these given data structures. All right, so those are examples, and we can also go to the next slide. And as we look at now for the specific list, specifically, I think we can talk about list as a linear data structure, and then look at different types of list data structures. Linked data structures. So if we say list or linked list data structure as a linear data structure, so we have different types of this data structure. So we have what we call the single data structure. That means single linked list data structure. We have also the double linked data structure, and then we have the circular. We have the circular linked list. We also have double circular linked list. All these are different examples of a linked list. Remember, linked list is what we call a linear data structures. And now every type that we see here of a linked list has different operations that can be applied on every type, and different ways through which that can be added. So we have seen the operations that can be applied on linear data structures. It is those operations that we can specifically apply on every type of a linked list that we see here. So now, like I said, the other operations we mentioned that can be applied on linear data structure, it is those operations that can be applied on every type that we have listed here. Now, let's work on a single linked list and see how we can do some operations, or see how we can create a single linked list, and also see how we can apply some operations on this single linked list. So yes, next slide. So a single linked list, it means it is this structure of list whereby it is made up of, okay, let's see the structure of the single linked list so that we can have a look at it as we work on it. All right, so as you can see from the presentation that we have a single linked list drawn. So we see it is made up of nodes. There is a start node, and we will see how this node, how this can be called a single linked list. So it always, for it to be called a linked list, that means we have a list of items that need to be linked. So how can they be linked? So we will see that we have every node in a list or in a linked list. Nodes are what we call, are made up of a data field and a pointer field. And every node must have an address. So there is always a starting node that is called the start node that must point to the first node of the list. So to point to the first node of the list, every node that makes up a list, it must have an address. Let's say this is address 100, this is address 101, and this is address 105, and this address 100, let's say, and 10. So for the starting node to be connected to the first node, it must accommodate the address of the first node. So we take 100 and write it here, and then a link is immediately created that creates the starting node with the first node. So this is the first node and this is the starting node. So the first node points to the address of the first node. The address of the first node is 100. So if we type 100 inside here, this link will immediately be created. And that creates a link between the starting node and the first node. So the first node, as we can see here, it is divided into two parts. The first part is what we call the data field, and the second part is what we call the pointer field. What does that mean? So the data field, like we say, the data structure, it is a structure of data that help us to store data easier within the computer. So the data field, it holds the data that we want to store. Let's say you want to store a reg number of student ABCD. Let's say we take his reg number, if it is, let's say it's 10, and then we store 10 here. So this is what we call a data. So now the remaining part is what we call the field, the pointer field. The pointer field, it always holds the address of the next node. So the next node, it is the second node that is made up of the list. So if we take 101 and write it here, immediately this link will be created. That means that this node is linked to this node. That is why we call it a single linked node, because it is linking the first node and the second node with the use of a single link. A single link, it is where this name comes from. We will see that when we look at the double linked list, we will find that these lines that are linking the first node and the second node, they are two directions. One goes this side, another one goes this side. And we will see that also the number of fields the node has, they are different. But let's first complete this one. Now for the second node, let's say it has the data that is 5. It accommodates data 5. And then we need to link the second node to the third node. What do we do? Any idea? Yes, that means we needed to take the address of the third node and write it in the pointer field of the second node. That means 105. This immediately tells us that we have a link between the second node and the third node. and the list continues the same way as we have done it before. So let's say here we have 10. If you have 10, let's say if you have 11 as the data, and now the feed is to point on this node. So that means we take 110, and this creates immediately this link. So if we don't have a link, if this is the last link, that the last node, it means it doesn't have another node to connect to it. In that case, the last field, for instance, if we have, let's say, 20 as data here, we have no any other node on this end to connect to. So in that case, we type this symbol within the pointer field of the last node, indicating that it is a null value. Or we can also close and write this sign. This sign says that it is a null value. It is not 0, but it is null value. That means it is waiting for a new node on this end to connect to. It means that every last node on the linked list, it must have this field as a last node. So now, this is how a linked list, single linked list is created. Now we can see, we are going to see how we can apply operation on this specific single linked node. Remember, let's recall on the operation that can be applied on linear data structure. So remember, we have add, we can add item, we can delete item, and we can also search item, we can sort item. So let's work on this. Let's work on the first operation, and then the rest operations will be considered next time. So we can work on the add operation and see how we can add a new node. So given that we want to add a new node on the given single linked list that we have here. We have a single linked list here, and we need to see how we can add a new node to the existing linked node. So it means where can we have 3 positions through where we can add a given new node to a given single linked list. First, we can add a new node to the beginning. That means beginning of the list, or in the intermediate of the list, or in the last or at the end of the list. So now, given that you are asked to add a new node on the single linked list, that means the lecturer must specify where exactly you want to add the new coming node. It is whether from the beginning of the list, or in the middle of the list, or at the end of the list. So let's say now we want to add the new node in the intermediate or in the middle of the list. Given a node of this form, let's say it is 21, and it has address of, let's say, 300. So this is the node is given in this form. So the node holds data of 21, and the address of that node is 300. And we needed to fix this node inside the existing node of this list. So the list will be like this. So we have a starting node, the starting node with 100 address. That means it points to the address. It points to the first node that holds. So let's say we want to add our new node here. That means we create the first 2 nodes. We link it the way we used. So we take this address, put it here, and then you create this link. And then, so this is where we want to add. This is where we want to add our new node. So we bring our new node in this form. That is 21, and then the address is 300. Who can tell me where we can place this 300 to? This 300, where can it be placed so that we create a link between this node and this node? So it means we have to bring this 300 address to this field, the pointer field of the second node, Once this is added here, immediately the link will be created. And once it is created, that means this link has been joined to the first two node. And then we need also to come to the third node. In this case, it is the fourth. In this case, it is the fourth, because we have already added another one. So it had 105, and the data was 11. So we need to create a link from this node to this node. That means we take the address of this node and write it in the address field of a new incoming node. That creates a link between the new coming node and the existing node, and that's the link is created. And then we bring the other last node, the last node with 20 data, and then the address was 110, and then we write it here, and the link is created. And remember, the other field of the last node, it must have a null value, and that's how a single linked list can be created, and that's how we can add an operation on a given single linked node. That operation we have worked on is addition. We added a new element or a new node on the existing single linked list as a data structure from linear data structure class. Thank you so much. That means we will continue from here by next time, looking at the remaining types of linked list. That was the double, circular, and circular double linked list. Thank you so much. See you next time. All right.